As developers, we often need to know the details of the system we are working on in order to optimize our code for maximum performance. That's where rocminfo comes in. Rocminfo is a command line utility that provides detailed information about the Rockim software stack and the hardware configuration of the system. It can be used to verify the installation of the Rockim software stack as well as to gather information about the installed hardware, including the number of GPUs and their specifications. With rocminfo, developers can quickly and easily access important information about their system's configuration and use to optimize their code for maximum performance. This can be especially helpful when developing GPU accelerated applications, as it allows developers to understand the capabilities and limitations of the system's hardware and tailor their code accordingly. If we have a standard Rockim installation on our computer, we will find rocminfo located in the opt/rockim/bin directory. Assuming this directory is included in our system's path variable, we can simply open a terminal and type rockinfo to access a wealth of information about our Rockim stack and hardware configuration. Rockim is built on the Heterogeneous System Architecture, which is also termed as HSA, a standard that defines a common hardware architecture and software interface for heterogeneous computing systems. With the rocminfo utility, we can easily access information about our system's attributes and agents, giving us a detailed understanding of our HSA-compliant hardware configuration. Within the Rockim environment, HSA system attributes are a set of metadata that provide valuable insights into the characteristics of a GPU and its associated system resources. Within the Rockim environment, HSA system attributes are a set of metadata that provide valuable insights into the characteristics of a GPU and its associated system resources. By accessing this information through the rocminfo utility, developers can gain a deeper understanding of their hardware and optimize their code for maximum performance. HSA agents serve as the backbone of a system, supplying essential compute resources like CPUs and GPUs. In Rockim, HSA agents can be broadly categorized into two types: CPU agents and GPU agents. GPU agents refer specifically to the AMD GPUs that are supported by Rockim. As we have mentioned before, by accessing the HSA system attributes through rocminfo, developers can gain valuable insights into the capabilities and configuration of their GPUs. This screenshot provides a detailed information available, including the runtime, version, system timestamp, frequency, machine model, and much more. Each HSA agent in Rockim has a unique identifier that enables communication and resource allocation for compute tasks. In this example, we see that Agent 1 has a UUID value that distinguishes it from other agents. Additionally, by examining the device type information, we can determine that Agent 1 is a 16-core CPU device. Likewise, Agent 2 contains valuable information that indicates it is a Radeon Pro W6800 GPU device. This GPU has 3 levels of caches with 16 KB, 4 MB, and 128 MB sizes. And the number of compute unit for the GPU is 60. Each compute unit in the GPU has 60 CMD units, so when the GPU is executing a program or kernel that can be parallelized, it can simultaneously execute up to 60 operations on different pieces of data using the same instruction within each compute unit. Each compute unit in the GPU has 60 CMD units. So when the GPU is executing a program or kernel that can be parallelized, it can simultaneously execute up to 60 operations on different pieces of data using the same instruction within each compute unit. This GPU has wavefront of size 32, that means 32 threads are executed in parallel on each compute unit on the GPU. A similar but commonly used tool is called clinfo. clinfo is a powerful tool for developers using OpenCL to access GPU compute resources. With clinfo, we can quickly and easily obtain detailed information about the GPUs installed in our system, including device name, vendor, driver version, available compute units, and more. These information can be critical for optimizing our OpenCL code and ensuring that it runs efficiently on our hardware. In the following sections, we will explore the key features and capabilities of CLInfo and discuss how it can be used to streamline our OpenCL development workflow. If you have a standard installation of Rockim on your computer, you should be able to access CLInfo by navigating to the opt/rockim/opencl/bin directory. If this directory is included in your system's path variable, you can simply run the clinfo command in your terminal to launch the tool. This can be especially useful when you are developing program using OpenCL. CLInfo is very similar to rocminfo. It returns details such as the number of OpenCL platforms installed, the devices that are attached to each platform, and their specifications, including the device name, type, and compute capability. This information can be extremely useful for developers who are working with OpenCL and need to optimize their code for specific devices. Not only does CLInfo provide comprehensive information about the OpenCL platforms and devices available on a system, but it also serves as a valuable tool for diagnosing potential issues with the OpenCL environment. In particular, running CLInfo can help verify that the OpenCL installation is configured correctly, detecting errors or warnings related to missing or outdated drivers, hardware, and OpenCL version mismatches. This makes CLInfo an essential resource for developers to want to ensure their OpenCL programs are running optimally and efficiently. Now that we know CLInfo is an essential tool for verifying the functionality of the OpenCL installation on a system and for ensuring that it can be used for programming and computation, let's execute the CLInfo command. Upon executing the clinfo command, the output provides valuable information about the available GPU processing units as well as the maximum number of work items that can be created in a single kernel invocation and the maximum number of work items that can be assigned to a single work group. These attributes are crucial for optimizing the performance of applications that can benefit from parallel processing. In the screenshot displayed, we can see that the device has 30 compute units and that up to 1024 work items can be created in each of the three dimensions. Additionally, the maximum group size is 256. This information can also be used to troubleshoot any issues related to the OpenCL installation, such as outdated drivers or hardware and software incompatibilities. So far, we have seen that rocminfo and CLInfo can show the properties of the devices that are available in the system. However, these properties are static properties. If we want to check the dynamic status of the GPUs or even want to configure the GPUs, we may need other tools. Therefore, our next video will cover another powerful tool called rocmSMI that can be useful for GPU management.